It only took 7 months, but I finally got enough free time to make Frame by Frame Season 2, Episode 1. For Season 2 of Frame by Frame, I want to take a look at neural networks, and mainly going to break down about how they work and why they're great for computer vision applications. For this season, I've created 10 videos that I'll be releasing and talking about different components of neural networks. For the first video, this one, it's just going to be me talking about the general structure of a neural network and how they work at a very high level and maybe a little bit of history about them. And then each episode after that is going to be breaking down the different parts of the neural network. So, jumping right into it, a neural network is a computational model that is inspired and functions very similar to the human brain. It is a subset of machine learning, and it forms the foundation of deep learning. We'll be mainly learning about classification models. These are used a lot in computer vision, and they show very positive results when they are correctly trained and tuned. Throughout all these videos, I'm going to be using this simplified example here. Oh yeah, I'm also using PowerPoint now. Neural networks are comprised of different layers. There's usually an input layer, several hidden layers, and an output layer. These circles here are called nodes or neurons, and they take input data and they process, they learn the data, and then they can give an output or a prediction based on the information it was given. So in its simplest form, a neural network's goal is to make predictions based on the information that it was given. Now the key word is make a prediction. So for example, we can train a model to identify different pictures of dogs and cats, and then we can feed an image into the trained model, and it will give us a prediction of how likely that image is either a dog or a cat. If we zoom in on one of these neurons, the neuron will be taking in different inputs, applying a weight and adding in a bias, and then sending that summed value through an activation function to introduce nonlinearity.
What? Bro, what are you talking about, man?
So that means that after the input data is given to the node, it computes it, produces an output, and sees if it reaches a certain threshold and sends that information to the next layer. It's very similar to how biological neurons are fired. A simple neural network might have a few nodes in it, about 10 or so, but more complex ones can have a couple hundred even. Now, more nodes does not mean it's going to be a better system. It just all depends on what you're trying to predict. Regardless, the same flow is still going through. So the input layer is going to be taking in the image, it goes through the nodes, and then it sends information to the next layer, into the next layer, all the way until the output layer when it tries to make a prediction about what is being fed into it. But the model is not going to know exactly what a dog or a cat is right off the bat. So we have to spend time to train it, much like you would train a child to learn what a cat versus a dog is. When training a model, we're going to be sending images through the model in what's called the forward pass. It's going to reach all the way to the output layer where the model is going to make a prediction based on what it's seen so far. So it's usually going to give a percentage, like a 50%. This could be a dog, could be a cat, I'm not really sure. We're going to take that guess and we're going to send it back through the model in what's called backpropagation. During this backpropagation, we're going to be adjusting each of those weights and biases so that the model can make a better prediction and learn from its mistakes. This forward and backward sending of data can continue a few hundred or 1,000 times, all the way until the model is saying, I'm 95% sure that this is a dog, or I'm 99% sure that this picture is a dog. And just to be clear, that this series is mainly going to be looking into classification models. That's where you give it a picture, a few pictures, and say, what is this in the image? Is it a dog, cat, human? There's other types of neural networks that do similar things with other non-computer vision related topics. So there's natural language processing, you got stock market predictions, you have email spam prediction, lots of different applications for these neural networks, but we're mainly going to be looking at some computer vision related topics. Some of the earliest research in the neural network technology can span all the way back to the 1800s with
Adrien-Marie Legendre
and
Carl Friedrich Gauss.
All the way back to when they were looking at planetary predictions, they would use regression models. Over the next 150 years or so, several mathematicians and scientists have put forth so many contributions into laying the framework for what is to become artificial intelligence. More modern contributions to neural network technology came around the 80s and 90s, especially when
Yann LeCun
introduced early convolutional neural networks. The main application for this was to identify handwritten addresses for mailing letters and packages. This was a large data set at the time, meant to match each image given to a true label to it. This was a supervised data set, meaning that each image had a true label that was assigned to it. So the whole thing was 60,000 images, and each image had a attached label saying that this is truly a 6 or a 7. God. Oh no! On the flip side of that, there's also unsupervised data sets, which means there's just a bunch of images without any labels in it. And the models will have to do what's called clustering instead of a normal prediction like this. And I hope to go over those in some future episodes sometime. Well, I hope you enjoyed that episode. In the next episode, we're going to be looking into the forward pass and a little bit more about what exactly a neuron is and mathematically how it all works together. So stay tuned for that.